This shit is wicked on these mean streets. None of my friends speak. We all trying to win. But then again, maybe it's for the best though. Cause when they seeing too much.
Hello and welcome to the video on parametric equations. So in this video, I'm just going to go over a few different, how to parameterize a few different kinds of graphs. Okay, so first of all, let's start with working in the plane in 2D. Okay, so let's say we have some graph here, and it looks like that. Okay, and the curve is pretty curvy. This is when t equals 0, let's say. This is our x and our y axes. And it moves this way as t increases. Like, let's say this is where t equals 4. We're at this point, this x and y coordinate. And then we keep going, keep going. Okay, so let's say this thing is curve C. Okay, I'm going to name it C. And basically, what it is C of t. This is not, right now, this is not a vector valued function. It's just, it'll just spit out points. Like the output is points, not vectors necessarily. But anyways, so this is what it's going to look like. So C of t is basically saying that each of the x and y coordinates is based on the variable t. Okay, so commonly t is referred to or is thought of as time, as representing time passed. Like this, for example, is the start point when nothing has begun yet. And then when time starts going along, it'll go t equals 1, t equals 2, t equals 3, t equals 4 right here. And then continue on the curve. Okay, so both of these, x of t and y of t, we've seen this before. They are both called parametric equations. Okay, parametric equations. Okay. And as I said before, this, right now, it is not a vector valued function. So not vector valued, okay? Not just yet. We're not drawing vectors to each point or anything. They're just points that exist there on the plane. Okay, and later on, as you might notice here, we only have an x of t and a y of t. But as we've already seen, kind of like a preview, there have been z of t before when we parameterized a line. So there will be z of t. That comes in when we're working in 3D. So that's for the three-dimensional case. That'll come in later. Okay, so just a brief summary here. So c of t is your parametrization. That's the terminology. Parameterization. And t is our parameter variable, also known as just as the parameter. Okay. And you can choose anything to parameterize. Later on, we'll also see theta. Theta could be a parameter variable, and etc., etc. So one thing that we could do is actually convert from x and y to the parameter variable. So to your parameter, which in this case, I'll just name it t, to parameter t, and we can actually do it back as well. So if you start with the parameter t, start with an equations in terms of t, then you can always switch back to x and y. So here's an example. So let's say we have to, it says the following, describe, and I'll give you a curve here, c of t equals 2t minus 4, comma, 3 plus t squared, in y equals f of x form. Okay, so here, what we're doing here is we're given our x and our y coordinates in terms of t already. So this is our x of t, and this is our y of t. But we do not know directly how x and y are related, but we can do that. We can work backwards, okay? So let's start with our x. This is the same thing as saying x of t, okay? So I'm just going to write 2t minus 4, and y, our given y of t, is 3 plus t squared. Okay, so what we're going to do is basically just solve for t using one of the equations. So I'll start with this equation up here because it seems like the simplest. So if we have x equals 2t minus 4, we're just going to solve for t. So we're going to add 4 to both sides. Then we get x plus 4 equals 2t, divide by 2, divide by 2. So we get that t equals 1/2 times x plus 4. Okay? So now what we're going to do with this is we're basically going to try to eliminate t from the equation entirely. So we're going to plug what I just circled in for the t spot in our y. Okay? So y is now, it's It's going to be 3 plus t squared is now 1/2 x plus 4, and all of this quantity squared. Okay, so now let's just simplify a little bit, and we'll solve for y. So y is going to equal 3 plus, and this is a 1/4, and then we have inside that foils out into x squared plus 8x plus 16. Okay, and then we'll just continue simplifying. So then we get, this is 1/4 x squared plus, and then 2x plus, and this would be 4 plus 3, so that is a 7. Okay, so this is actually our, this is like our f of x. Y is a function of x. And see how we eliminated that parameter t from the equation. Okay, so now that I finished talking kind of generally about parameterizations, let's go into detail about what you do with certain types of curves on the plane or in your graph. So first of all, we can do parameterization of a line. Parameterization of a line. We've gone over this kind of briefly in a previous section. So let's go a little bit more in detail and technically. So the first way you can parameterize a line is based on what you're given, right? So what if you have a line through, and you're told that it goes through a point P, so A, B, with slope M. So then we have with slope M, okay? So the way you would do that is your x parametric equation would look like something like this, like a line in itself. Okay, wait, hold on back here. I'm going to put an R here, okay? And our y coordinate would look like something similar, but just with different variables, right? So, and this is as t goes from negative infinity to infinity. So this is all the real numbers, okay? So this is going to be your parameterization for each of your x and y based on t, all right? For any, and this is important to note, r and s, such that r is not equal to 0, such that, st stands for such that m is equal to s over r, okay? And these two equations here, the x and the y equations, they actually come from, or they just match up with our vector parameterization of a line. Remember that was t times v arrow plus op naught arrow. Okay, so this was the point that we started at, or when t equals 0, then this part goes away and we're left with this. This is like our y-intercept, okay? So this is this AB, this is the point we're starting at, because when t equals 0, then these go away, right? And anyways, and then when t is something, an actual like non-zero value, then that means that the r, or our v comes in here, and likewise in our parameterization now, we have our r and our s that come in, and y changes by a factor of s every time you add 1 to t, right? So s is kind of like our slope for the y, that's our rise, and r is our run, how much you're changing the x based on t. So that would be the run. So the slope, the overall slope m of our line is going to be s rise over r for run. Okay, so that's the first way to parameterize a line. Well, don't worry, we'll go over an example of this. And the second way, it's like I said, it's based on what you're given. So let's say we have a line going through, and we have a point P. So again, this is AB, and Q, which is CD. Okay, so the parameterizations would look like x equals A plus t times c minus a, and then y is going to be something similar, just with different letters, right? So t times d minus b. Okay, so this one, it comes from when we have the vector parameterization of a line going through 2 points, and remember that one looked like r of t is equal to t times oq plus 1 minus t times op arrow. Right? This is when we were given 2 points, and we didn't know the vector v, our slope. So here in this parameterization, we do not know the slope m or anything like that. So we have to kind of just work with what we have with these 2 points. So what we had to do, again, another way to write this is that if you factor this out in here, if you distribute it, then we have 1 OP plus, and then we have a T times OQ minus OP. And that's kind of the form that you see here, right? We have a something here, which is like our A or our B, right? And then we have a T, okay, T, T, and multiplied times another something, so from the other point, okay, the C and D are from another point, and then minus that original point there, okay? So I'm like circling everything, but I'm just trying to show you the symmetry between what we're doing now, what I'm teaching you guys now, and what we've already gone over in the previous videos. Okay. Alright, so now we're on to parametrizing circles.
In my body, it used to say, fuck my skills. I never prayed to God, I prayed to God. That's right, it's wicked. That's life, I live it, ain't asking for